Iron Man, one of the most popular superheroes in the Marvel Cinematic Universe. He wears a superpowered iron suit that is a masterpiece of futuristic engineering and fictional technology. Let's explore the real-world issues with Tony Stark's Iron Man armor. 1. The arc reactor problem. One of the biggest challenges of the Iron Man suit is energy, having enough to power all of its functions. In the MCU, Tony Stark creates a miniature arc reactor that provides virtually limitless energy to power the complex functions of the suit, including flight, life support, weapons systems, and more. But the reactor has two major real-world problems that break the laws of thermodynamics. The energy density required for such a device far exceeds what is remotely achievable with any known technology today or in the future. An even bigger problem is the need for the arc reactor to be incredibly efficient to avoid overheating. A device generating that much energy would create ungodly amounts of waste heat, and dissipating that heat would be a massive problem in a confined space like the Iron Man suit. 2. The problem of flight. The Iron Man suit is equipped with repulsor technology that allows Tony Stark to achieve his controlled flight. Unfortunately, in the real world, there are major problems with the Iron Man suit coming close to even flying. First, the thrust-to-weight ratio. Earlier Iron Man suits would weigh several hundred pounds. To achieve flight, the repulsors would need to generate an enormous amount of thrust to overcome the suit's weight. This is similar to how rockets work, except the repulsors are depicted as vastly more efficient and compact than any known propulsion system. The repulsors seem to work without any visible mass being ejected, raising questions about what type of energy or force Tony is using. The third problem with flight are the G-forces that would be created when flying in the Iron Man suit. Even if the suit could achieve flight, the kind of acceleration that Tony Stark undergoes during quick maneuvers would result in extreme G-forces. The human body can withstand about 9 Gs, or 9 times the force of gravity, for short periods before losing consciousness. The Iron Man suit, with its rapid changes in direction and speed, would subject Tony Stark to G-forces, well beyond what a human body could handle, that would result in severe injury or death. Another major problem would be the amount of heat that would be generated. Just like the arc reactor, the repulsors exert an enormous amount of power and break the laws of thermodynamics. 3. The problem of armor durability. In the MCU, the Iron Man suit has near godlike durability, able to withstand bullets, explosions, and massive impacts from superhuman and supernatural forces. Nothing even close to vibranium exists that could offer the level of protection the Iron Man suit provides in the movies, while still being lightweight and flexible enough for Tony Stark to move freely. Tony Stark moves with complete ease, performing acrobatic maneuvers that are impossible for someone encased in heavy armor. Even the best real-life ballistic armor, such as that worn by soldiers, offers protection against bullets, but is very heavy and limits mobility. There is also the problem of kinetic impacts. In many scenes, Iron Man takes massive blows from large objects and opponents such as Thor's hammer, the Hulk, or falling from extreme heights. The amount of kinetic energy transferred in such impacts would cause severe damage to both the suit and Tony Stark. Even if the armor could absorb most of the force in these massive blows, the sudden deceleration or acceleration would result in internal injuries that would kill him instantly. 4. The problem of weaponry and ammunition. The Iron Man suit is equipped with a variety of weapons, from repulsor blasts, missiles, and lasers. While futuristic technology allows Stark to carry such an arsenal, the physics behind storing and deploying these weapons pose significant problems. There are major issues with the miniaturization of weapon systems. Storing enough ammunition or missiles in a suit the size of the Iron Man armor would be impossible. Each weapon requires physical space for its components, as well as a source of energy or propellant. Even if we assume that the arc reactor can power some energy-based weapons like lasers, the physical limitations of space make it hard to explain how such an array of weaponry is packed into the suit. These installed missile and weapon systems would also make the Iron Man suit a lot more fragile, with every kinetic impact destroying or even exploding these weapon systems. There is also a major problem of heat and recoil when firing the Iron Man suit's high-energy weapons, which would need to be managed by the suit's systems. 5. The problem of life support and sustenance. In the MCU, the Iron Man suit provides life support for Tony Stark in various environments, including outer space, underwater, and in high-altitude scenarios. The Iron Man suit would need to have a pressurized air supply and recycling system for carbon dioxide released by Tony Stark's breathing, as the suit must be self-contained like a spacesuit. These are not visible anywhere in the suit, and if they were, they would be incredibly bulky. The fragile nature of these systems would make them hard to protect and keep safe in a fight. You have to consider the energy consumption to maintain life support systems as well. Regulating temperature and providing breathable air requires a constant supply of energy. Given the suit's other demands, like propulsion and weaponry, it's questionable whether enough energy could be supplied without depleting the arc reactor. If we assume that the arc reactor can easily power everything the suit needs it to, it would all fall back to the biggest problem the Iron Man suit has, the law of thermodynamics.